Again, welcome to Python programming language. In this lectures, we're going to discuss about objects and methods in Python programming language. So this is the beginning of object-oriented programming concept in Python programming language. So our main objective is to program using characters and strings. Also, we are going to introduce objects and methods, which is our main focus on these lectures. Also, we're going to introduce the methods in the str class. Str stands for string class. So this is a built-in package or a string class that have a lot of methods. We shall go through some of the methods. Also, we're going to learn how to convert hexadecimal character to decimal value. Also, we're going to learn how to format numbers and also strings using the format function. Again, Python language comes with a format function, which is again a built-in function, and we can use it to format our data or values, especially decimal values and integers. For example, in the decimal values, we can specify how many decimal places we need, and also how many whole numbers we need. For example, we may have a value that we format it to be 10 characters with 2 decimal places. So we're going to have 10 digits. So it's going to be 10.2, which means the total digits are 10, but the last 2 is 2 decimal places. Again, we will see an example soon. So first, let's start with the introduction to objects and methods. Here we said that in Python language, all data, including numbers, characters, strings, they are actually objects. So in Python language, anytime we declare variable, actually we are declaring an object. And an object is an entity. So each object has an ID. ID stands for identity, and also have a type. The type stands for the type of data that object can have. So example of an ID would be a unique number, which for every object we have in our program may have its own number. That number we use to identify the objects. And also the type will be if the object carries a string or carries a numbers. So objects of the same kind may have the same type, which means if I have 2 objects and they all carries or we can store a whole number, then both of them are the same type, which is integer. So you can use the ID function and also type function to get this information from an object. So this means if we have an object already declared and we don't know the type, we don't know the identity, unique number, then we can use the ID function to get the unique identity number of the object. Also, we can use the type function to tell us if the object contains a value or a characters, etc. So this is an example of using the ID and type functions. But normally these 2 functions, normally we don't use it often. It's rarely used in programming. Because most of the time we don't need the unique number of the variables or the objects that we have in our program. Also, the type depends on the type of data we store. For example, in Java programming language, when we declare variable, we have to state the type of data that can go to the variable. With Python, we don't need to do that. When we have a variable, the content of the variable will tell us the type of data it is or the type of object. So for example, here we have n equal to 3. So n is our object. And 3 is a whole number or an integer. So again, if I use the ID function with the argument of the variable name or the object name, it will give me a unique number. So this number, 505,408,904, is a unique identity number of the object n, or we can say also variable n. Now, if I use the function type with the argument of the object name n, it will give me the type of data that can be stored or has been stored in the variable. So here we know the value 3 was assigned to the variable. So the answer will be entity or int. Int stand for again integer. So again, the object n is an entity, or we can say variables. So the type depends on the data that is stored in. Here we assign a whole number 3. So the type will be int or integer. Integer means it's a whole number. So we have another variable, I would say an object, f. We assign 4.0, which is a decimal value. In Python or Java, decimal value is the same as a float. So here, if I use the identity function ID with the object name, f, it will give me a unique number. Now, if I use the type function, it will tell me the type of data that has been stored. In this case, it's a decimal value or float. So it will return float. The previous one returned int because it's a whole number. Now we have another object here called s, or variable. And we assign a string to it, which is welcome. Now the same thing, if I use the identity function, the argument of the identity function will be the object name s. It will give me any unique number. Now, if I use the function type s, it will tell us the type of data that has been stored in the variable s or the object x. And this is a string. str stands for string. A string means we have a characters, it can be 1, 2, more in double quotation. So OOP stands for object-oriented programming. In our future lesson, and we will go detail about how we can also define our own class, how we can create our own class. Here we are using built-in classes by Python. So object-oriented programming concept is using classes, the instance of classes, we have objects, etc. We may go detail on this. So this is an example we went through. When we create an object, we assign 3 to it. When we use the ID function, this is the unique number that was given to us. And since we assign 3 to it, if I use the type function, I'll get int. Same thing apply with f. We assign 3.0 value to it, which is a decimal value. So if I use the ID or identity function, it will return a unique number of the object f. Now, if I use the type function, it will return float. And also the string, which is s, we assign welcome, which is a string again. That's why the object for str is welcome, it's a string. So here again, we repeat that ID and type function are rarely used in programming, but they are good, again, pedagogical tools for understanding objects. But we rarely use it, especially the ID, because normally we don't need a unique number or the identity of the objects. The type function, we may use it, but again with Python, any value we store to a variable, or in this case, an object, that tells us the object type. So if I store float, then that variable becomes a float type. If I store int or integer, it becomes int. So here we said that if we have for n equal to 4. Again, for n equal to 4, we can say n is an integer, it's a whole number that holds the value 4. Here we are assigning 4 to n. Again, 1 equal sign means assignment. I'm assigning n to 4. And also, strictly speaking, n is a variable. So n is a variable that references an int object for the value of 4. So for simplicity, we normally would say that n is an int variable with a value of. And the equal sign here means assignment. So we assign 4 to the variable n. And since 4 is an int, the value or the type of the variable n will be int, and the value will be 4. So next we move to a method. Normally in object-oriented programming, every object has 2 things. The data, which we call the instance variables, as we went through some of the variables. So normally that would be the characteristics of the object. Then the methods will be the behavior of the object. So for example, I may create an object, or let's say a class named vehicle. From the class vehicle, I may create an object named a car. So one of the data or the characteristics of the car or the variable will be the color of the car. Is it a 4-wheel drive? The model, etc. Now the behavior of the car, which we call the methods, will be with a car, we can drive it, we can park it, we can reverse it. Now, if it's an employee class, maybe we can calculate employee salary, or we can check if employee is late. These are the method behavior. In this case, the data or a variable for an employee can be the number of hours he works and his hourly rate, or address, name, etc. So next we go to the methods. Here we say you can perform operations on an object. So we always say objects will be the methods will be the behavior of the objects. So the operations are defined using functions. And the functions for the objects, again, are called method. Now there's a difference between the two words. A function means you have some code, a set of code that perform a specific task. A method also the same thing. You have a set of code that perform a task. That's why we say the behavior. But the difference between the two is that a function can be a standalone function. A function doesn't belong to a class, but a method belongs to a class. So when I want to use a method on anything, or on an object, first I have to make sure I create the object. And then when I create the object using the class, now all the class members and the data or the methods can be used by the method, in this case by the objects. So methods can only be invoked from a specific object. That's what I'm trying to, because again, method belongs to a class. So when I want to use a method, I need an object to work on it, because we say the behavior of an object depends on the method. The methods are the behavior of an object. So for example, here we have a string type. It has the method such as lower method, where lower method is to convert uppercases characters to lowercase, or upper method, this will convert lower cases to upper cases. Actually, lowercase will convert upper cases to lowercase. Upper will convert lower to upper. So here to return new strings for lower method, it will return lower cases. For upper method, it will return upper cases. So we can see an example how we can invoke these methods. So first we have an object or a variable named s, and we assign a string welcome to it. Next, first of all, we want to use a lower method. What we said previously is that anytime we want to use a lower method, we have to invoke the method, the object, because we are going to use the behavior or the tags on some object. So here the object is s, and here we are saying s.lower method. This means I'm going to convert all the characters in s to lower cases. So here we say this will invoke the lower method. So anytime we invoke any method, we have to include the object that we are going to use. and also the period. So this is more or less an access point. So now, if I said, first of all, the welcome, the W is uppercase. But since I'm converting everything to lowercase, W also become a lowercase. So our result S1 gives welcome with W lowercase. Same thing, we can use the object S and convert all the characters to uppercase. So next one, and when I do that, I will assign the result to S2. So when I call S2, it will give me welcome, but everything now is lower, uppercase, everything is uppercase. So the lower method will convert everything you have to lower cases. And upper method will convert everything we have to upper cases. Again, these are built-in methods inside the string class. That's why we call lower and upper as a method, because they belong to a class named string. So next is stripping beginning and also the ending whitespace characters. We have a special method named strip. A strip means, again, taking something away. So for example, if I have a character and I have some space in the front or anywhere in the middle, I can call the strip to remove the space method to remove. Or if I want to remove anything, I'll call the strip function. And the argument will be what I want to remove. So if I'm removing a space, then I don't need anything. I just press the space. Space is like an object, a character. It's a value. Now, if I want to remove a value or a symbol, then I'll put that symbol here. But before I call string, I also the same thing. I have to attach the object to it. The object, the strip against a behavior. What I want to use the strip on, which will be an object. The object name should come first. So we're going to see examples soon. So here we say another useful string method is the strip, which can be used to strip the white spaces character from both ends of the string. So example, we have S again. We assign welcome to it. But the welcome have a tab space. Normally by default, the tab can be up to like 5 spaces. Then also \n is a new line, which means we have a new line. So now we call the strip method with the s.strip to invoke the strip method on S object. So you can see that next time when I print S1, it will remove all the spaces around it. The space before W and the space after W. So we can see welcome, there's no space. So again, the strip method is used to remove white spaces characters from both ends of the string, beginning and the end. So these are some of the string methods inside the string class. Again, these are all built-in. So let's go through some of them. In the future, we may use some of this method in our program. So here we have is a norm. So is a norm, which is ISALNUM. So this method normally will return true. Anytime we have a method charge starting with is, it's like we are checking a condition. So the condition can be either true or false. So here we said it will return true if all characters in these strings are alphanumeric. And that's what we mean. ALNUM is alphanumeric. And there is at least one character. So that will return true. To tell us that whatever we have is alphanumeric. Now we also have is alpha. Is alpha means it will return true if all the characters in the strings are alphabetic and there is at least one character. So you know in an alphanumeric, we include both characters and numbers. But with is alpha, it will return only value because alphabetic. So that will be alphabetic, will be characters or not values, characters. Now we have is digits. So now digit is numbers. So again, alphabetic characters. Digit will be whole numbers. So this will return true if the string contains only number characters. We also have is identify. This will return true if the string is a Python identifier. And also we have is lower. Previously we have lower. The lower method will convert uppercases to lowercase. But is lower, we are checking if the value we have in the object is a lowercase or not. So this will return true if all the characters in the strings are lowercases. And there's at least one character. And that is lower method. Same thing applies to is upper method. We are checking the condition to see if all the characters in the method that we are using is uppercase or lowercase. So it will return true only if all the characters in the strings are uppercase. And at least we have one character. Otherwise, it will return false. The next one is space. We use space a lot. If we are checking and we say, okay, is the first value a space or not? Because sometimes it's difficult for us to know if there's a space in between. So this will return true if the string contains only white space characters. Also searching for substring. A substring means a part of a string. So for example, I may have a string customer. The substring can be cost, or the substring can be NER, which is part of the ordinal in the string. So sub means part of something. So here we have a method ends with S1. So this will return true if the strings again ends with a substring S1. Same thing, start with S1. This will return true string start with substring S1. Now find S1 means we're going to return the lowest index where S1 starts in this string. So when I'm searching for something, we return the location of it. So if we are using array, then we are going to return the index. And then our find S1 also can return the highest index where S1 starts in the string, or -1 if S is not found in the string. Okay, so again, we continue. Here also we have the count substring. I think the main keyword is count. So this will return the number of non-overlapping occurrences of this substring. So it will count. And as we said, the R funds means to return the highest index. S1 is our object, so S1 starts in this string. We can also convert in strings. We have a built-in functions or methods inside the string class. Example can be capitalize. Capitalize means we are going to return a copy of the string with only the first character capitalized. So Charles, if C is lowercase and I use capitalize, it will only convert the first case to uppercase. But if I want to convert everything to lower upper cases, then I'll use upper method. So upper method returns a copy of the strings with all the letters converted to uppercase. Capitalize will return the string with the first character converted to as uppercase. Then lower method will return a copy of the strings with letters again converted to lower cases. Then we also have the title method. And this method title normally returns a copy of the string with the first letter capitalized in each word. And then we have a swap case. This also returns a copy of the strings in which lower lowercase letters are converted to uppercase letters, and uppercase are converted to lowercase. So that's why it's called swap case. If I have a word welcome and it starts with uppercase W, if I call the method swipe case, it will convert the uppercase W to lowercase, and the rest of the cases lowercase to uppercase. So it will be welcome uppercase W E lowercase E L C O M E. If I call the swipe case method, it will convert it to lowercase W uppercase E L C O M E. Also, we have the method to replace. So replace take three arguments. First, what we want to replace. Second, what we are replacing with. And then end will give us the number of characters that we are replacing. So this will return a new string that replaces up to n number of occurrences of the old with a new string. So n will be the number of occurrences of the old that we are replacing. We also have the stripping the white space characters. As we said earlier, we have a method called strip. We have else strip, which returns a string with the leading white space characters removed because it's left. Now R, which will be right strip, it will return a string with the trailing white space characters removed, that's to the right. And regular strip will return a string with the starting and trailing white space characters removed. So strip will remove everything left and right. But R strip will remove right side. L strip will remove left side. So return a string with the leading white space characters. And then next we can format numbers and strings. In Python to format items, we can also use the format function. So the format function formats a number or a string and returns the string. So this is the syntax. We have a format method. Then what you format the item, and also the format specifier, whether I'm formatting to a whole number or a decimal number or a string. So we have to specify the type of format. So this example here, we use the print method to print something on our screen, but we call the format method. And the format method, the arguments have the value that we want to format. And then the type of format we want here, by looking at this, we have 10.2F, which means we are going to have up to 10 character space, then 2 decimal places, 0.2F, F means point, so 2 decimal places. So the answer is somewhere here. We say it. So we have 574. Okay, so that's it here. We have 57.47. Since the decimal is only 2, we approximate, since here the 10th digit is 7, we approximate it to 6 to 7. So the answer will be 57.47. But we make sure that the number of digits is 10, which is 7, 10.2F, 10. So we have 10. And the next one also the same thing. We have 1, 2, 3, 4, 5, 6, 7, 8.923. But we want to make sure we have 10 digits, and the last 2 digits is decimal. So this is up to 8, then 9, 10, so it will be 0.92. Then 57.4, if it's 10 digits, we have some few characters in the front, which will be 5. Then we have 0.4, 2 decimal places, so it's the same as 0.40. So this is another example. Here we said that if you change the conversion code from F to E, the number will be formatted in scientific notation. So here we have the same value again, but this time instead of saying 10.2F, which is float decimal place, we say 10.E, which is scientific notation. So see the 2 decimal places, we can see 5.75. But this time we are using E plus 0. And all the digits will be 10, including the plus also. The second one, We have 10.2 again, 2 decimal places. But we need the value to be a whole number because scientific notation, you should have a value that lasts the 2 values. There should be a period between. So scientific notation means the whole number should be anywhere between 1 to 9. Then scientific notation, first one, we have 5.75 E plus 0.1. We move the decimal places once. Here we move it 1, 2, 3. So it will be 3.3. And this time we are going to count the number of digits we have. It should be 10. And then we should have 2 spaces between. So that gives us 3.39 E dash 03. So they are all 2 decimal places, 0.2 E, 0.2 E. Again, A is for scientific notation, F is for decimal. So formatting as a percentage, the same concept. So here we have a number 0.53457, 10.2%. So which means we have up to 10 digits, and then we have 2 decimal places. So instead of 456, we approximate it to 46. Then we have 2 decimal places, 1, 2, 3, so it will be 53.46. Same thing applies here, 2 decimal places, it will be 0.3. And we have 33923, so approximately it will be 34. So we have the number of digits, which is 10 total. So the same thing applies also here. We are using F again. So that will be decimal place. So we have 5.5, 7.46, 7657, 10.2, which means we need 10 digits, and then 2 decimal places. So that's what we have here. We can also format as integers. Again, when we format as a scientific notation, we use E at the end. Now, when we format as a decimal value, we use float F. Same thing, if you format as an integers, a whole number, we use the symbol D. So 52832, 10D means we are going to have up to 10 whole number. Here, integer, D stands for the integer, so we don't have no decimal places. So we count the number of digits should be 10. So the same thing we can do for formatting strings also. So for example, here we say welcome to Python, then 20s, which means we can have up to 20 characters, or the string size is 20. And that's what we have here. So we're going to, if it's not up to 20, we're still going to leave space. So that will be the conclusion for our lectures. Again, these lectures we focus on built-in functions, and we saw the examples of especially the string class, built-in methods, and the concept of objects. So again, wish everybody the best.